All right, we're in video 2 now, and we're starting with question 4, but we're just kind of rolling through the vector addition kind of introductory stuff from 4.1. So what we have here is basically what we had in 3, except the difference being 3, they give it in a story problem, and in problem 4, the vector is just kind of given to you as the magnitude and the angle at which it's being pointed. So they're asking for the component form of the vector and the information. So all we're going to do here is, let's see what, that's a little thick. We'll go blue. All we're doing is we're being asked, what is the vector in component form? So we just simply say magnitude times cosine the angle, comma, magnitude sine of the angle. And then we close it. And that's it. Like there's nothing more to do with it. I suppose I'll take that back for a half a second here. You can take 120 in your calculator times cosine of 310 degrees in degree mode, and you could get an approximation. If I can find some room here, that looks like 77.1 and negative 91.9. Okay, so B, same thing. You're taking 41 times cosine of 150 as your x component and 41 times sine of 150 the y component. So let's do C. We've got some room. I might even do this and move that over. See if I got room here. So V, vector V, in component form looks like magnitude, so oh, do I have enough room? Yes. Oh, except I don't have room for the little vector sign. There you go. So again, if you plug those in, vector V, sorry, equals, well, cosine of 180, looks like a 6, doesn't it? Sorry. Cosine 180, well, that's your x. That's a full 1. Cosine 180 is actually negative 1. So your answer is negative 5.25, comma, and then the sine of 180 is 0. So you get 0. Which, if you think about it, like in graphing that, your vector, theta is 180, so I'm going this direction, right? Well, if you wanted to graph that in an xy starting at the origin, because you're in component form, you got to go negative by the magnitude in the x and 0 in the y, because you're 180 degrees. So it all makes sense. If I got room here, I'm going to do vector V. And that one is just 41 cosine 150 sine. Which then becomes the rounded answer, negative 35.5 and 20.5. You guys check your numbers again. Like if I were to graph that, 150 degrees, where does 150 put me? From positive x-axis, that's 90, that's 180. So I should be somewhere in this vicinity, somewhere in quadrant 2. Well, do my x, y values match that? Yes, negative x, positive y, and everyone's happy. So now we're going to move on, see if we can get question 5 knocked out. Change the color again. So over here, they're giving us the component forms of vectors u, v, and w. And question A just says add u and v. So we're going to do that. We're going to say u plus v means we're going to take the x component of u plus the x component of v, and we'll get an answer. Then we're going to take the, I guess I'll do that. Then we'll take the y component of u plus the y component of v, which really just reduces. So we say 3 plus -8, so -5, and 1 plus 4, +5. And that's your answer. B says subtract the two vectors. So B, we're going to take 3 minus -8. We're going to take 1 minus 4. And what we get for a vector is 11, comma, -3. It's as simple as that. That's all we're doing in question 5. Part B. C is a little bit different just because we have to find what 3 times the vector u equals. So we're going to find what 3 times vector u equals, and we're just going to multiply that constant out front by the two components. So 3 times u is really 3 times 3 and 3 times 1. So that's 9, comma 3. So 3u is 9, comma 3. So 3u minus v minus the v vector, and 3u minus the v vector. So our answer, 9 minus, so that's 17, comma 3 minus 4, -1. Sorry, I'm going to cut that off. So 17, comma -1 is your answer. So anytime you have a constant out front, just make sure you take your original vector, multiply both x and y by that coefficient first, and then do the adding, subtracting. V plus w, not a whole lot different. V plus w, it just means we're taking new numbers. So v plus w in the x, comma v in the y, plus w in the y. -8 minus 6, that's -14. 4 minus 2 is 2. There you go. So again, those are pretty straightforward. Don't think it's terribly difficult. 6, you know what, I've got time, and this kind of ends the introductory stuff, adding, subtracting vectors in component form. So let's do 6 really quickly. So the only thing I'm going to say first is, I guess I should change that to a different color again. I'm going to rewrite these. Use the margin here. Vector u, I'm just going to turn u and v into component form. These are what we call standard form. So x times I, comma, y times j is what we're really doing here. So u is 8i, so really that just simply means 8, comma 0. Okay, and the reason is the I is really tied to the x term, and there's an implied plus 0j. So that's where we put the 0 in here. It might help also if we look at the vector v. Yeah, whoop, sorry about that. It's not going to let me, I'm too close to the edge. Okay, vector v, story of my life, right? Way too close to the edge. All right, vector v, 6i, that just means I'm going to put a 6 first. Minus 4j means I'm going to put a -4 next. So really all we're looking at doing with this stuff then is taking u plus v like we did before. So 8 plus 6, 0 plus -4. 14, comma, -4. See, it doesn't change. It was just simply that your vectors had changed from component form to standard form. So now u minus v, u minus v says 8 minus 6, and 0 minus -4. So that's 2, comma, 4. The only thing I might add while I'm in here, if you were to have to answer these, maybe let's say it's a matching or a multiple choice, we might want to take just a quick second and convert these back to standard form. So what that looks like is 14i minus 4j. It's the only thing I should add that in, just because we can convert to the standard or component form from standard doesn't mean we shouldn't go back to the standard form. So again, this one, the 2 comma 4, is just written, again, just throw an I in front of the x term plus, not in front of, after the x term, and then put a j after the y term. So 2 comma 4 is just a positive 2 coefficient on the I, positive 4 here. This was -4, so we said 14 minus 4. I'm going to pause just to make sure this video doesn't go too long. I will write out question C, but I will fast forward that. So I'll pause here, do the work, and then just recap it. Okay, boom, there you go. I first want to note I took 3 times the vector u. So instead of 8 comma 0, I'm at 24 comma 0. I took 3 times both the 8 and the 0. 2 times v for the minus 2v looks like 12 instead of 6, and -8 instead of -4. So when I subtract those, 24, 3u, minus 2v, 24 minus 12 gets us 12, and 0 minus -8 is really 0 plus 8. So we get 12 comma 8, and in green we have the standard form, 12, throw an I after it, plus 8, throw a j after it. So there you have it. That is all of the introductory stuff in vector adding, subtracting, component form, standard form, all that good stuff. All we have left is some airplane problems. So let's get to those in our next video.